The procedure of the 50 TPH silica sand processing plant. The raw materials are silica sand, and most of the sizes are smaller than 2 millimeters. Therefore, we suggest using a belt conveyor feeder to feed materials to the plant. The belt conveyor feeder generally will with a hopper. We can offer the plates of the hopper, then finish building the hopper at your mine site. The belt conveyor will send the raw materials to the trommel screen with 2 mm stainless steel to do primary washing and screening of the big size waste materials. The more than 2 mm waste materials will be sent away by a belt conveyor. The under-screen materials will go to the attrition scrubber. The scrubbing process can effectively remove the thin film iron, bonding, and mud impurities on the surface of silica sand through mechanical force and the abrasive force between sand particles, further purifying the silica sand. After being processed by an attrition scrubber, the slurry will go to a thickening cone to remove mud. The overflow is mud and will go to the tailing pool or sedimentation pool. The underflow will go to the next screening process. Because you told us that most of the sizes are smaller than 0.6 millimeters, the next screen mesh size will be 0.6 millimeters. The plant feeding capacity is 50 tons per hour, but the screen mesh size is very small, 0.6 millimeters, thus need to use several sets of trommel screens to do the screening process to have a better effect. Then the more than 0.4 millimeter coarse size sand will be sent away by belt conveyor. All the less than 0.6 millimeter slurry will go to the next process. It's a hydraulic classification tower. The main function of the silica sand hydraulic classification tower is to classify silica sand through hydraulic classification technology to improve the quality and purity of silica sand. Working principle. The silica sand hydraulic classification tower uses the power of water flow to sort silica sand. Specifically, the equipment adjusts the speed and direction of the water flow so that silica sand particles of different sizes have different settling speeds in the water, thereby achieving separation. This method can not only effectively classify silica sand by size, but also remove dirt and other impurities in it, improving the cleanliness of the silica sand. It will remove the less than 0.1 millimeter tiny sand, then remove mud again, and they will be sent to the tailing pool or sedimentation pool. Then the underflow will go to the next process, the gravity separation, generally using spiral chutes to process. For the spiral separation process, generally use 2 stages. For your capacity, the first stage process can use 14 or 15 sets, each set spiral capacity of around 3 tons per hour. After processing by the first stage spirals, the middlings from them will go to the next stage spirals, generally using around half the amount of the first stage, and can use 6 or 7 sets spirals. Then all the concentration from the 2 stages spirals will go to the next stage magnetic separation process. All the tailings will be sent to the tailing pool or sedimentation pool. For the magnetic separation process, generally use 2 types of magnetic separation. The first one is the drum magnetic separator. Its Gauss intensity generally will be around 4,000 Gauss for removing strong magnetic minerals. Then the concentrate from it will go to the second separator. It's a high-gradient magnetic separator, and its Gauss intensity is adjustable, generally between 10,000 to 14,000 Gauss. It's the best type of magnetic separator and can remove weak magnetic materials as much as possible. All the tailings will be sent to the tailing pool or sedimentation pool. The concentrate from HGMS will go to a thickener to accelerate the concentrate sedimentation. The underflow will go to a dewatering screen to do dewatering, then sent away by a belt conveyor. The overflow of the thickener is clean water, which also will go to the tailing pool. The water of the sedimentation pool can be reused.